Okay guys, I'm going to finish the notes from today real quickly and kind of review the concept for today. So we were on number 4 from the notes on the back. So if you would, let's just kind of review where we were. We were solving for x, and our exponent is 2 to the x, like our power. Base of 2 to the x is what we need to isolate. So we're going to multiply both sides by 5, and we get 2 to the x is equal to 125. And then we would take the log of both sides, log here, log there, so that we can bring the x down front. So I end up with x times log of 2 is equal to log of 125. So to solve for this x, I simply divide both sides by log of 2. So let me show you what this would look like on the calculator. So let me make sure it's clear for you. I'm going to take, actually I'll just do it on the computer screen here. I'm going to take the log, so just press the log button, and it's going to be the log of 125. Be sure to close the parentheses and then to divide by the log of 2. So log of 2, just like that. And then we were supposed to round to the 100, so it's going to be 6.97. So let's kind of think about why that's the answer. So the answer is 6.97. So if I go back to the original, and if I were to raise 2 to the 6.97, let's just see what that would give us. So 2 raised to, and I can just call this back up, recall it by doing second answer, and then of course I'd have to take half of that, or multiply that by 1/5, so divide by 5, which is the same as multiplying by 1/5, and I get 25. So just kind of checking our work there. If I had 2 to the 6.97 and then I multiplied it by 1/5, it does take me back to the 25. So that is indeed the answer, just kind of showing you where things fit together. Okay, now this bottom section here is a mixture of review and a mixture of the new stuff. So it's a really good thing to do as we have the test coming up next week. So what I want to do is I want to remember that if I have a power times a power and I have the same base, I simply add the two exponents. So I'm going to get 3 to the 5 plus 3, which is 8. And then if you had the calculator and wanted to do that, you could simplify that out, but that's really what we're testing for right there, is that you know how to do that. Okay, now, number 2, I have x to the 8 divided by x to the 5th, and this is when you're just going to subtract and say x minus 5. I'm sorry, 8 minus 5, and that's going to be x to the 3rd. Okay, and I'm now noticing that my computer all around is having trouble, but I'll continue on. You'll just kind of, I apologize for the delay. So number 1 down below is sort of like our new material. It's kind of a combination. So I have 7 as a base here and here. So I'm going to simply add these two exponents together. So I'm going to say 7 to the 2x plus 5 and add that negative 8. And then I can actually combine this together, and I have 7 to the 2x, and then 5 minus 8 is a negative 3, is equal to 12. Now, because 7 and 12 do not have a common base, I'm going to just take the log of both sides like we've been doing. So log here, and that allows me to bring the power down front and turn it into a multiplication. So I have 2x minus 3 multiplied by log of 7, and that will equal log of 12. And what you have to remember is that log of 7 and log of 12 are just numbers. They're numbers our calculator will give us. So I'm going to go ahead and divide both sides by log of 7. So this will be gone. So I'm down to 2x minus 3 is equal to log of 12 divided by log of 7. This is just a number our calculator will give us. Then I will add 3. So that'll be gone. So let's go ahead and do that, and we'll be down to 2x is equal to whatever all this simplifies down to. So log of 12 divided by log of 7. So log of 12, close your parentheses, divided by log of 7, and then get that value. And then I want to add 3 to that. And then at that point, I have 4.28. So let me go back, and that will be set equal to 4.28. And then, of course, I would just divide by 2 to finish off my x. So 4.28 divided by 2. So just divide that by 2. And you get 2.14. So your answer there is 2.14. Now the good news is we're going to practice this some more, so it's not like you have to know all of it today. Okay, number 2, we're going to basically use our properties of exponents, and we're going to subtract. So I have 4 to the 5x minus, and be sure to put this in parentheses, 3x plus 1, like that, is equal to 18. So it looks kind of weird, but it's just a property that we learned early in the unit. So if I have a common base and I'm dividing, I just subtract basically the bottom exponent from the top exponent. So simplifying all this out, remember you'll distribute a -1 here and here. So it's going to be 4 to the 5x minus 3x, which is just going to be a 2x. Let's go ahead and combine that. And then this will be a -1 is equal to 18. So here again, I'm going to take the log of the left and the log of the right, and then bring this down front. So I get 2x minus 1 times the log of 4 is going to be equal to the log of 18. Okay, and then I would divide both sides by log of 4, and then I would add the 1, and then eventually divide by 2. So x is going to be equal to log of 18 divided by log of 4, get that value, add the 1, and then eventually I will divide by 2 again. So let me kind of show you how that looks. So log of 18 divided by log of 4, add 1, and then divide by 2. So log of 18 divided by log of 4, get that value, and then we added 1, get that value, and then you divide by 2. So I'm kind of thinking ahead a couple steps, but 1.54 should be the answer there. So all this is going to simplify down to 1.54. And again, I apologize for all the issues with my computer. Okay, now let's go to number 3. And number 3, I have a common base of 3. So I'm going to multiply these by adding the exponent. So I have x plus 1 plus x minus 1 equals 10. So I'm going to end up with 2x as my exponent. X, and these are going to cancel, is equal to 10. Now this is a good, pretty straightforward one, except we have a multiplication going on here, so it's a little bit different there. But log here, log here. Then bring the 2x down front. And so then I'm going to have 2x times log of 3 is equal to log of 10. Divide both sides by log of 3. So I get 2x is equal to, and it's whatever we get here. So I'm going to do log of 10 divided by log of 3 on the calculator now. So log of 10, close parentheses, divided by log of 3. I get that value is 2.096. We'll go with that, 2.096. And then we just want to divide both sides by 2. So x is going to be, and since I have this right here, I can just do divided by 2, just recall it back up, and I get 1.05. So 1.05 is our x down here. And then number 4 is again another subtraction. So I'm basically going to have 10 to the 4x minus x minus 1. You just have to be careful with that. And then I get 10 to the 3x, and don't forget to distribute that, and you get a plus 1 is equal to 55. And I would take the log of both sides, log here, and then the log there. So this comes down front, so 3x plus 1 times the log of 10 is equal to the log of 55. So divide both sides by the log of 10, getting rid of that, and then I would get that value, and I would subtract 1. So I end up with 3x is equal to all of this. So let's go and do that in the calculator. So log of 55 divided by log of 10, and then I get that value and I subtract 1, and then I go back and basically remember it's 0.70. It's going to be 3x is going to be equal to 0.740. I'll go with 0.7404. And divide by 3, divide by 3. It doesn't really matter because when I go right into the calculator and divide by 3, I have all of that precision. I'm keeping all of that in my answer, so my answer will be very precise. I'm not losing anything by doing it this way. So then I get an x which is 0.25. And you can always go back and kind of check it and make sure that gives you the right answer. All right, so let's do a few from the homework itself. And here was the final answer for number 4 there. All right, so from the homework, I'm just going to pick and choose a couple of problems, just to kind of get you going. So when I look at number 1 and number 2, both of these can be rewritten with a common base. So I'll just pick one of them to do. I see that 25, I can't raise it to a power and turn it into 125. But I can take a base of 5 here and a base of 5 there. So 5 squared is 25 and 5 cubed is 125. Then I have to make sure I have my exponents there and there. Now that I have a common base of 5, I can just focus in on the exponent. So I have 2x minus 2. Don't forget to distribute. So 2x minus 2 is equal to 12x. And I would subtract 2x from both sides and divide by 10. So x is going to be a negative 1/5. I know I'm going kind of quickly, so you can just pause it and kind of work through it on your own, but I get a negative 1/5. Number 2 is essentially the same, obviously a different base, but you can try that on your own. When I get down to number 3 is also very similar, so I'm not going to do that one either. Number 4 is one of our new ones, but it's the basic type. When I see that I don't have a common base, I have my power isolated, so I can go right in and take the log of both sides, log here and kind of squeeze in a log there. And then the beauty of this is the x comes down front. So I have x times log of 3 equals log of 7. And then I just divide both sides by log of 3. So x is going to be log of 7 divided by log of 3. So log of 7 divided by log of 3. And I get 1.77. So that is the answer to that one. Okay, number 5 is essentially the same. You have a little bit more work to do there. You have to add that 1, but we did enough of those. Let me go to one that's a little bit more complicated, maybe like number 11. I just want to make sure I hit a couple of the ones that are harder. So number 11, I know that I need to isolate to that power right there. So to do that, I would add 4 and then divide by negative 2. So when I add the 4, I'm going to get a negative 12 here. And then I'm going to divide by negative 2. So that cancels. So I'm down to x to the x minus, 7 to the x minus 2 is equal to a positive 6. And this is when I take the log of both sides. So I have log of 6 there. And I have log on the left side. And the whole reason I'm doing this to both sides is so I can bring this x minus 2 out front. So x minus 2 times log of 7 equals log of 6. And I'm going to say this a lot. These are just numbers your calculator is going to give you. So right here, I would divide both sides by log of 7. That will divide away or give you a 1, and then I'm going to add 2. So that will be gone as well. So I have log of 6 divided by log of 7, get that value, and then add 2. So log of 6 divided by log of 7, be sure to close your parentheses, get that value, and add 2. So your answer will be 2.92. Okay, so that just leaves you, for like 9 to finish off on your own, okay, for tonight's homework. And we will be continuing this concept tomorrow, so if you have questions, please come prepared to ask those questions. And you guys have a great evening.